Okay, here's a question. This is question 2 from chapter 5.2. And this one's confusing only because of the wording. It's kind of overly theoretical, but you have a sample space in which you have the numbers 1 through 12. So that's 12 different outcomes. What you can imagine is like rolling a 12-sided die. And then you have two events. F, which event F would happen if 3, 4, 5, or 6 was the outcome, and event G, which is 9, 11, and 12. So if you roll a 9, 11, or 12, G happens, and if you roll a 3, 4, 5, or 6, F would have happened. Okay. Now we're supposed to assume that each of the outcomes is equally likely. That's why the die metaphor works well here. Is that when you roll a die, supposedly each number is equally likely to come out, unless you've got weighted die or something like that. Okay, so now you're just supposed to list the outcomes in F or G. Now remember, when you're putting together things with an OR, we have to be really pay extra attention in this chapter or this section 5 about and or. When you're putting together things with an OR, that means that one or the other or both of them could happen, right? So if you see this person got B right, because if you roll and you get a 3, a 4, a 5, a 6, a 9, or 11, either F or G happened, okay? And it's kind of important to note between F and G, it'll be important later, that there's no number that's both F and G, okay? But if you got any of the numbers separately of either F or G, you would have F or G happen. Okay, now so you're supposed to find the probability in part 2 here. The probability of counting the number of outcomes in F or G, and you're supposed to do it by counting. So really all that's saying is to count up the number of outcomes here, and I take it there's 7, right? And divide that by the total number of possibilities, right, which is 12. So there's 7 ways to get either F or G, and there's 12 things that could happen overall. So the probability of F or G is really just 7/12. Okay. Now, so here it says it wants us to find the same probability, 7/12, but to do it by the general counting or general addition rule. And that is when you're looking for the probability of two things happening, right? So here it's the probability of F or G, right? That's equivalent to the probability of F, right, plus the probability of G minus the intersection, right, of probability of F and G. That's terrible. Okay. So now if you look at the event F, right, that only has that has 4 ways of happening. So the probability of F is 4 out of 12, right? There's 12 things that could happen overall. The 4 of them would mean F happened. And G, if you look at G, there's 3 ways for that to happen out of 12 things that could possibly happen. Now, because there's no number, if you roll a 12-sided dice, there's no way to get a 3 or 4 or 5 or 6 and to get a 9, 11, or a 12. The probability that F and G happens at the same time is 0. Okay. So really 0 divided by 12 is just 0. So it's really just these two added together. 4/12 plus 3/12 is equivalent to 7/12. Okay. These two answers should be the same, right? It's really just using two different rules to compute the same probability. One's just a pure counting, and then the other one is actually using this addition rule that you probably read about in your textbook. Whoops, I missed part of the addition rule. All right, I hope that helps a little bit.